Welcome to this video. In this video, we are going to find out the probabilities. In the previous videos, we were talking about the number of ways you can select R objects out of N objects, or number of ways you can arrange R objects out of N objects, and so on, right? But here what we will do is we will find the probability. For example, let us say that there are there are 10 students in a group. Okay, there are 10 students, so let's say 4 of them are boys and then 6 of them are girls. Okay, if you select one student, what is the probability that you are selecting boy? That will be, there are 4 boys in total, right? And then you are selecting out of 10, right? So out of 10 you are selecting, so the total number of the people are 10 in the class. Okay, and then the number of boys is 4, so the probability of boy is number of boys divided by the total number of people, or total people in that room. Okay, if you select a girl, so probability of a girl will be 6 out of 10, right? 6 divided by 10. Now you are selecting only one here. You are selecting only one. But if you select 2, so select 2. If you select 2, how many ways you can select 2 people out of 10? Because the total number of people there is 10, right? So in the denominator, it will look like this. So probability of, let's say, 2 boys. If you select 2 boys, then how many boys are there? 4. So you can select 4 boys out of, you can select 2 boys out of 4 boys is 4C2 divided by the total number of people there is 10 and you are selecting 2. Look at that. Look at the difference here. Here you are selecting only one boy. So the total number of boy there is 4 and total number of people there is 10. That's why you did 4 over 10. But if you select 2, what is the probability that both of them are boys? Is there are total 4 boys. Previously you have just 4 over 10, right? But you have now, since you are selecting 2, you need to do C2 there, that way. Okay, so here you are trying to do the probability, trying to find out the probability of 2 boys. Since there are 4 boys, you can pick 2 boys out of 4 boys in 4C2 ways, and the total number of ways goes to the denominator, that is, you are selecting 2 out of 10, that is 10C2, and you simplify that and get the final answer. Okay, so what do you get there will be, I think you will get, so this will be 4 factorial over 4 minus 2 factorial and then 2 factorial, right? So 4 times 3 is 12, so it will be 6 out of, it will be 10 factorial over 10, you can use calculator to find out this, 10 factorial over 10 minus 2 factorial is 8 factorial, so it will be 36, I think. So 30, so it will be 36. Okay, I think it will be 36. So basically it will be 1 over 6 total. Okay, all right, let us do, so this this combination, to find out the probability, combination is used if you are selecting more than one. If you are selecting just one, you can do the number of that over total number, right? For example, for the girl, you did number of girl is 6 over 10 if you are selecting one. But if you select 2, then you need to use the combination there. For example, what is the probability of both girls? 2 girls will be, there are total 6 girls. You can pick 2 girls out of 6 girls by 6C2 ways, and the total is again 10C2. And then if you do that, you will get, I think, 15 over 36. Is that 36? I'm not sure, because it will be 10 times, I don't think it is 36. It is 10 times 9 is 90. I think it will be 45. Okay, 6 out of 45 will be 2 out of 15. 2 over 15. I think that's what you get. 2 over 15. And here 6C2 will be 15, right? And then 10C2 will be 45 again. 45. So if you simplify that, it will be 1 over 3. Okay, let us do these examples, then things will get clear. Find the probability of getting 3 face cards when 3 cards are drawn from a deck without replacement. Okay, so this is without replacement. All the problems in the combination is also without replacement, so we don't need to worry about that. So how many face cards are there in total? In a pack of 52 cards, so face cards are considered as Jack, Queen and King are called the face cards, okay, because they have some picture in it. So how many face cards are there in the pack of 52 cards? There will be 4 times 3. 4 times, I think 4, right? So 16 for face, no, 4 times 3, not 4 times 4. It will be, so how many face cards are there in total? So Jack, King and Queen are the face cards. So there are 4 Jack, 4 King and then 4 Queen. So the total 12 face cards. So how many you are picking? Pick 3, right? So what is the probability that all 3 are face cards? That's what it is asking, right? So probability of 3 face cards is equals to, so 12C3 over 52C3. That's what you get. If you are picking only 1 card, that will be 12 over 52. But you are picking 3, that's why you need to do 12C3 divided by 52C3. So just use calculator to find out that. So when you use calculator for this, you will get, the top will be 220 divided by, the bottom will be 22100, 22100, right? So this will implies 0.00995. So this is less than 1%, right? So it is unlikely to happen that when you pick 3 cards from a deck of 52 cards, the probability of getting all 3 cards face card is highly unlikely. All right, so let us do example 2. A box has 5 red balls and 2 blue balls. Let's do that. So 5 red balls and then 2 blue balls. Oh, sorry, 7 blue balls. 7 blue balls. 2 balls are drawn. Pick 2. If you were picking just 1, then probability of red ball will be 5 over 12 and probability of blue ball will be 7 over 12. But you are picking 2. What is the probability that both are red balls? So probability of 2 red balls will be, how many red balls are there? 5 C2, because you are picking 2. If you are picking 1, it will be 5 over 12. The total number of balls there will be 12. You are picking 2. Just use calculator to find out that. I think it will be 10 over 12 times 11 is 132 divided by 2 will be 66. So that will be 5 over 33. That's what you will get if you use calculator. Okay, both are blue. How do you do that? Probability of both blue, 2 blue balls, right? Since you are picking 2, you should use combination. If you are picking 1, it will be, the probability of blue ball will be 7 over 12, right? But you are picking 2, so you need 7 C2 over C2. How much is that? 21 over, that will be 66. If you divide by 3, you will get 7 over 22. That's what you get. And 1 red ball and 1 blue ball. This is a little bit different from the other one. So what you want to do is probability of 1 red ball and then 1 blue ball, right? So you are picking 2 again, but 1 red and 1 blue. So you want to pick 5 C1 times 7 C1. You are picking 1 red and then 1 blue. I use C but 1 there. Divided by 12 C2. See, 1 plus 1 is 2 basically. You see that 2 and 2 are equal here, 2 and 2. So 1 plus 1 is 2. So you are picking 1 red ball, 5C1 wedge, and then 1 blue ball, 7C1 wedge, and 12C2. How much is that? This will be 5 times 7 over, this will be 66, right? So it is 35 over 66. This is the probability. Okay, so the same concept, but you have 2 terms there. This is because we want to pick 1 red ball and 1 blue ball. That's why you need to consider both. And then 1 there is because we want to pick 1 red ball and 1 blue ball. Let us do example number 3. A package contains 12 registers, 3 of which are defective. So how many are good? This is a packet. 9 are good and 3 are defective registers. 4 are selected. Select 4 out of 12, right? Find the probability of 0 defective register or all non-defective. 0 defective. So you want to pick 0 defective and then all good. That is same as all good, right? How do I do that? It will be probability of 0 defective. Let me do it here. Probability of 0 defective is same as all 4 picked were good, right? So how many ways you can do that? You are picking 0 out of 3 and then 4 out of 9, right? 9C4 over 12C4. That's what you do. Okay, what do you get? You will get 3C0 is 1 times 9C4, 9C4 divided by 12C4. You use calculator to find out that. If you use calculator, you will get the top part will be 126 and bottom part will be 495, and then you will basically get 0.2545. So this is the 0 defective registers. Okay, so second one is 1 defective register. You are picking 4 again, don't forget that. Okay, 1 defective register means probability of 1 defective. How many should be good? 3 good, right? 1 defective, 3 good register. So what is the probability? 1 defective can be picked from 3 is 3C1, right? And then times 3 good means 9 out of 9 you are picking 3. Divide by 12, right? 12C4, 12C4. So the bottom is same as the previous one, 495, 495. The top is 3 times 9C3. Let me find out that in the calculator. And if you use calculator, you will get 5091. This is 5091, 0.5091. 3 defective register. How do you do that? 3 defective means, so you are picking 4. Don't forget that. 3 defective means you need to pick 1 good, right? So probability of 3 defective and 1 good will be, you are picking 3C3 times 1 good will be 9C1 divided by 12C4, right? What do you get? 3C3 is 3. 3C3 is 1. So 3C3 is 1 times 9C1 is 9 divided by 495. So it is 9 over 495 is how much? 9 divided by 495 is 0.1818. 0.1818. This is what you get. Okay. So example 4 is similar to the example number 3. Okay. So how do you do that? The red face cards and the black cards number 2 through 9, total 16. How many red face cards? There are 6 red face cards, and then black cards number 2 through 9 is 16 because 2, 3, 4, 5, 6, 7, 8, 9. So spade and the club, the total will be 16, are put in a bag. So let us make that bag. So 6 face cards, face red cards, right? And then 16 black card between 2 and 9. The total is 22. 22 total, right? And then 4 cards are picked. So you're picking 4 cards. Pick 4 cards. Find the probability that all 4 cards are red. What is the probability of 4 red cards? How many red cards are there? 6, right? So you do 6C4. Are you picking any black? No. I would write 16C0 divided by 22C4. You use calculator for this, okay? 6C4 times 1 over 22C4. You use calculator and plug in there. Next one is 2 are red and 2 are black. So probability of 2 red, 2 black. What is the probability of that? You are picking 6C, 2 out of the 6 red times 2 out of the 16 black. C2 divided by 22C4. Similar to the last one, at least one of the card is red. So at least one card red means probability of 1 red, 3 black plus probability of 2 red, 2 black. You are picking 4, right? Plus probability of 3 red, 1 black, and then plus probability of 4 red and then 0 black, right? So you find out the probability of each and then add. So what is the probability of this? Is 6C1, you are picking 1 out of 6, times 16C3 over 22C4 plus 6C2 times 16C2 over 22C4 plus 6C3 times 16C3 over by the way, 16C1, right? Because you are picking 1 blue, over 22C4 plus 6C4 times 16C0 over 22C4, and then you add them all together. The last one is all 4 cards are black. How do you do that? So this is this one, okay? This is that one, and this is that one. Now let me do that. All 4 cards are black, meaning probability of 0 red and 4 black. That's what it means, right? So it is 6C0 times 16C4 divided by 22C4. In all the problems you can see that, see, one, if there are more than 1 terms multiplied, the sum of the subscript, right, must be equal to the subscript of the C on the denominator. So the numerator sum and the denominator must be equal there. So you use calculator and you get the final answer there. And the very last problem, a football team consists of 20 freshmen, 20 sophomore, 15 juniors and 10 seniors. 4 players are selected. Again 4 are selected. Find the probability of all 4 are senior. How many are in total? 20 plus 20 is 40 plus 15 is 55 plus 10 is 65. So 65 total. And 4 picked. 4 students are selected, right? What is the probability that all 4 are senior? How many seniors are there? 10. So 10C4 over 65C4 is the answer for that. One of each, freshman, sophomore, junior and senior. How do you do that? Is 20C1, freshman, 1 picked, times 20C1 times 15C1 times 10C1. So picked 1 from each category, divide by 65C4. And you use calculator to find out the final answer on these. And the 2 sophomore, 2 freshmen. So how many freshmen are there? 20C2 times 20C2 again, because this is for the freshman, this is for the sophomore, divided by 65C4, and use calculator to find out the final answer. Alright, that's the end of chapter 4.